this is Matt at LSAT Lab, and today's lesson is on evaluate questions in the logical reasoning section. And while they're not very common, there are about 1% of all logical reasoning questions are evaluate questions. It is one that has been cropping up a little bit more lately. It's coming on people's radar, and it's something that you probably want to pay attention to. It's not terribly difficult. It's very similar to either a strengthened question or a weakened question, but just that slight difference can catch people off guard. In this lesson, we want to cover how to spot an evaluate question, what the process is for approaching one, what the reasoning structures are that you should be aware of when you're working on one, and what are the trap answer patterns that you want to be on the lookout for as you're working through the answer choices. So here's an evaluate question, and you'll notice that there's the word evaluate sitting right in the middle of the question stem. And in fact, you're going to find this on every single version of an evaluate question. It's going to ask you what would be most useful to know in evaluating the conclusion drawn above. So what this question is basically asking you for is they want to know the answer to something that if you were to answer that question in one way, it would support the argument, whereas if you would answer the question in another way, it would undermine the argument. So essentially, it's some piece of information that if you knew something about would either strengthen or weaken the argument depending upon how that information came back. So here's another question stem, and you'll notice that the word evaluate is sitting right in the middle of the question stem. The only difference between this one and the last one is that this one is asking for the answer choice that would be least useful in evaluating the argument, meaning 4 of the 5 answer choices would be helpful. They would give you information that would allow you to figure out whether the argument is more likely to be good or more likely to be bad, but the one that is the right answer is essentially irrelevant. Now let's talk about the process that you want to take when you're working on an evaluate question. It's the same that you want to use whenever you're on any question type in the assumption family. And that's where the evaluate question type sits. So you want to find the conclusion of the argument, find the evidence for why they say it's true. You want to evaluate that reasoning, meaning you want to judge it, figure out what the gap in the reasoning is, use that gap to anticipate an answer, and then use trap answers as you work through the answer choices to make eliminations. Now, the major reasoning structure that you want to pay attention to when you're working on evaluate questions is the comparative reasoning structure. 81% of evaluate questions rest on comparative reasoning. So that's where they're comparing 2 different things and maybe say that you should choose one over the other. Maybe they talk about the size of a city as it grows over time. But there's going to be some comparison made between either one thing at 2 different points in time or 2 things at one point in time. So here's an example question. Go ahead and give this question a try on your own. When you think you've got an answer that you like, go ahead and hit play again, and we'll review it together. All right, welcome back. So remember, the first step is to find the conclusion of the argument. And in this case, it's the last part of the last sentence. It is therefore safer for a dog to receive the vaccine than not to receive it. What's the evidence that they use to support that? Well, basically everything else. For every 50 dogs that contract a certain disease, 1 will die from it. A vaccine exists that is virtually 100% effective in preventing this disease. Since the risk of disease from complications of vaccinations is 1 death per 5,000 vaccinations, they go on to conclude, therefore, that it's safer for a dog to receive the vaccine than not to. So if we start to look at this argument, you can see that they're comparing the 2 states. What is safer? Is it safer for the dog to get the vaccine or not to get the vaccine? Because there's risks on both sides. So what do they tell us? Well, we know that we're comparing vaccinated or being vaccinated versus not being vaccinated. And they tell us that 1 in 5,000 dogs that is vaccinated is going to die from this vaccine. Now, what about the dogs that are not vaccinated? Well, in order for us to figure out the risk to these dogs of not being vaccinated, we need to know a couple of things. We need to know what's the likelihood that this dog will contract this disease, and then what's the likelihood that the dog would die if they did contract that disease. So that gives you the risk associated with not being vaccinated. And some of this information we were given already. They tell us that 1 in 50 that contract the disease is going to die. But what they don't tell us is what percentage of dogs are going to contract the disease. How likely are they to face this risk? If the likelihood of this risk is high, then the argument is probably pretty good. But if the likelihood of contracting the disease is low, that could push the risk level down below the risk of actually getting vaccinated. And then the argument would be bad. So what we really need to know is what's the likelihood that a dog will contract this disease. So if we look at the answer choices, answer choice A says the total number of dogs that die each year from all causes taken together. Well, all causes taken together are completely not relevant to this argument. That's out of scope. We can get rid of A. B says whether the vaccine is effective against the disease in household pets other than dogs. And well, pets other than dogs, again, aren't being discussed here. The conclusion is simply about whether it's safer for a dog to receive the vaccine than not to receive it, but we're talking about dogs. So let's get rid of B. It's out of scope. Answer choice C says the number of dogs that die each year from diseases other than the disease in question. Well, so long as those diseases are affecting both groups equally, it shouldn't have any impact on whether it's safer to be vaccinated against this particular disease or not. So those other diseases are simply out of scope again. D, the likelihood that a dog will contract another disease such as rabies. Again, those other diseases are not relevant here. Let's get rid of D. It's out of scope. E, the likelihood that an unvaccinated dog will contract the disease in question. That's exactly what we were looking for. We can pick E with confidence and move on. So they're not terribly difficult questions necessarily, but we do need to remember that the answer, like the information that this answer choice will bring us, could be presented in a way that would make the argument better, but it also could be presented in a way that would make the argument worse. So if the likelihood that an unvaccinated dog will contract the disease in question is high, well, then maybe they should get vaccinated. But if the likelihood that the unvaccinated dog will contract the disease is low, maybe they shouldn't. So now let's talk about another reasoning structure that you're likely going to have to deal with, which is the issue of causation on evaluate questions. Causation plays a role in 33% of evaluate questions, which is fairly comparable to the role it plays on strengthen and weaken questions, making it a major player. Let's look at an example here. Go ahead and try this question on your own. When you think you've got the right answer, hit play again, and we'll find out. All right. Okay. So in this one, again, we're going to start with the standard process. So what's the conclusion? In this case, the last sentence, the conclusion from these results, that's a nice little tip that there's the conclusion, is that high salt diets are linked to high blood pressure in rats. Okay. So high salt diets linked to high blood pressure in rats. What's the evidence for that? Well, they tell us that a few months after the experiment began, standard tests of the rats' blood pressure revealed that about 25% of the colony had normal, healthy blood pressure, about 70% of the colony had high blood pressure, and 5% of the colony had extremely high blood pressure. Okay, so these rats generally have high blood pressure, and we know that they've been feeding on a high salt diet. Okay, well, so now we've got this correlation between eating this high salt diet and exhibiting high blood pressure. Does that mean that the high salt diet caused the high blood pressure? Maybe it did, but that's jumping from correlation to causation. And we don't necessarily know that the high salt diet caused the high blood pressure. It could have been something else. Or, these numbers are actually kind of strange because they're telling us what percentage of rats have these characteristics, but is that normal or is that excessive? Usually what you have is some kind of an increase in the high blood pressure rate and then them saying that it's caused by the high salt diet. But this case, we don't actually have an increase or any kind of necessarily a change at all in the rat's blood pressure. We just know that we took a snapshot and 70% have high blood pressure and 5% have extremely high blood pressure. But what would that have snapshot look like before the high salt diet began? If it would have looked the same, then there's no way we could say that the high salt diet caused their high blood pressure, particularly because they hadn't tried that high salt diet yet. So that would be an example of the rats exhibiting the presumed effect without the presumed cause. Right? So that would weaken the argument if the rats were already exhibiting high blood pressure in around the same percentage that they exhibited it during the study or at the end of the study. So when we're weakening causation, we really want to be thinking about alternative cause, cause without effect, and effect without cause. And when we're strengthening causation, we want to do the same, but we want to work through an elimination of those things. But essentially, that's what we want to have in our mind as we're looking through the choices. Primarily, is it possible that the rat's blood pressure had experienced no change compared to before the high salt diet began? We could also be thinking about maybe alternative causes. Maybe it was something else besides the high salt diet that caused the high blood pressure, and the high salt diet actually had no bearing at all. Right? So maybe alternative cause, maybe effect without cause. Those would be good ways of kind of thinking about how we could undermine the argument. And if we can find an answer choice that at least points to one of those two things, then we have a good candidate on our hands for the right answer. Answer choice A says, how much more salt than is contained in a rat's normal diet was there in the high salt diet? It almost doesn't really matter how much more salt there was. What we care about is whether there is any effect that is actually being measured in the statistics that were reported. So whether it's a little bit or a lot of bit more salt, it doesn't make a difference, because that little extra, whether it's a little bit more or a lot of bit more, both of those could be responsible for an increase in the blood pressure. But until we know that there's an increase in the blood pressure, it doesn't really matter. So answer choice A is simply focusing on the wrong difference. We care about the difference in the rat's health, not in the difference between the rat's diets. So let's go ahead and get rid of answer choice A. Is out of scope. Answer choice B says, did the high blood pressure have any adverse health effects on those rats that developed it? Well, this is kind of like an effect of the effect, but this doesn't tell us whether or not the presumed effect happened as a result of the cause. So this might be like more information than we really care about. We care about whether or not the diet caused an increase in high blood pressure. Whether or not the high blood pressure went on to cause some other bad things doesn't really matter. So this is out of scope again. Let's get rid of B. Answer choice C says, what percentage of naturally occurring rat colonies feed on high salt diets? Well, whether this is a naturally occurring phenomenon or not a naturally occurring phenomenon, what we care about is whether or not when they exhibit that behavior, they eat high salt diets, does it lead to a particular result? So this is again out of scope. D, how many rats in the colony studied had abnormally high blood pressure before the study began? Well, this is getting to the point about whether or not the high salt diet actually caused anything to occur within the rats. Because if they had already had high blood pressure, then the salt diet didn't necessarily cause anything. Now, if they didn't have the high blood pressure, then it makes it more likely that the high salt diet caused the high blood pressure. So this looks pretty good. Let's hold on to answer choice D. Answer choice E says, have other species of rodents been used in experiments of the same kind? And what's happening with those other species of rodents really isn't at play here. What we care about is, did this presumed cause have a presumed effect within these rats? Maybe if they gave us some information about maybe some other rodents having a high salt diet but not getting high blood pressure, but they didn't give us that information in this question in answer choice E. So let's get rid of it. It's simply out of scope. And that leaves us with answer choice D is the right answer. Now notice, every single wrong answer we've looked at so far has been out of scope. And that's what you're going to find when you're working on evaluate questions. Essentially, because you're looking for something relevant, and that something relevant could either strengthen or weaken, each of the wrong answers will simply be irrelevant, or another way of describing that is out of scope. So in terms of trap answers, your job is simple. You're going to be just getting rid of anything that's out of scope. So remember, the process for working on evaluate questions is to first find the conclusion, then second, find the evidence for why it's true, then third, evaluate the reasoning, find the gap in the argument, fourth, anticipate what an answer might sound like based off of that gap, and then use trap answers to work through the wrong answers as step 5. You spot an evaluate question with the word evaluate. They all have it in there. And the reasoning structures you really want to be on the lookout for are comparison, 81% of the time they have it, and causation, 33% of the time they have it. Obviously, that leads to more than 100% because some questions contain both, and every once in a while you might even see a question with conditional logic, although that's extremely rare. Primarily, you're looking for comparison, and occasionally you're looking for causation. The trap answers to pay attention to are out of scope. That's it. And that's it for today's lesson. So I invite you to check out some of these other lessons or visit us today at lsatlab.com.